Bismillahirrahmanirrahim. Assalamu alaikum. Dear viewers, I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. Our today's lecture is about structure of ethyne according to hybridization. Ethyne is actually an example of the alkynes. So, with the concept of this lecture, you would be able to find out the structure of any alkyne according to hybridization. So, let us begin. So, now first of all, as you know that the atomic number of carbon is 6 and its configuration is like 1s2, 2s2, 2p2. So, here 2, 2 and 1s2, the total number of electrons become 6. And if we split or we organize the electrons in the degenerate p orbitals, then the picture looks like this. Here in 1s there are 2 electrons, in 2s there are 2 electrons, in 2px there is 1 and 2py also contains 1 electron. And the energy level of all these orbitals increases from bottom to top. And this is the ground state configuration. The electronic configuration at ground state of the carbon looks like this, and at the excited state the electronic configuration becomes like this one. Here, what is the change between the ground state at when we move from the ground state to the excited state? When the carbon atom absorbs the energy, then 1 electron from this 2s orbital jumps to the 2pz orbital, and here there becomes only 1 electron, 1 over here, 1 here, and the 1 electron from this orbital is in 2pz orbital now in the excited state. Now what happens in the case of ethyne? Only 2s and 2px orbitals would intermix to form 2 hybrid orbitals that would be represented like sp. So here, after hybridization, 1s orbital would contain the same as in the previous cases, the 2 electrons, but in sp hybrid orbitals that are at the same energy level and are of equal shape or same shape. So, in every sp orbital, as s orbital also contains 1 electron and 2px also contains 1 electron, so here both of these would contain 1 electron in each of them. So, these sp hybrid orbitals would be partially filled. The remaining 2py and 2pz orbitals would contain the 1 electron in each of them, and these would be unhybridized. The unhybridized orbital would be at the same energy level as in the excited state or in the ground state, but the sp hybrid orbitals would become or would lie in between the energy level of 2s and 2px orbitals. So, 2px is at a bit higher energy level and 2s is at the somewhat lower energy level, but sp hybrid orbitals lies in between these 2 atomic orbitals. So, now next point comes about their alignment or their orientation in space. As there are only 2 hybrid orbitals, so the electrons in these hybrid orbitals would lie as far apart from one another as possible, and for the sake of this concept they would come out to be in linear geometry. So as you know that there are two sp hybrid orbitals and they would be drawn at 180 degree from each other. This is sp and this is also sp hybrid orbitals, and both of them contain one electron in each of them. So now the structure of ethyne, if we write down its formula, that becomes like this: HC triple bond CH. So here there is one hydrogen attached with each carbon atom, and these hybrid orbitals are of this carbon atom. For example, because both of these carbons would behave identically, so for the sake of simplicity you can consider either this carbon atom or this one. If we consider this carbon atom, then it has two hybrid orbitals that were sp hybrid orbitals, and one hybrid orbital would be overlapped with the hydrogen. As you know that the atomic number of hydrogen is 1, and that is 1s1. The electronic configuration of hydrogen is 1s1. So here this 1s orbital of the hydrogen would overlap with the sp hybrid orbital of the carbon atom, and the other sp hybrid orbital of this carbon atom would form a sigma bond with the other carbon atom, that is this one. So this carbon would also behave identically, so that would also contain two sp hybrid orbitals, amongst which one sp hybrid orbital would pair up with the other carbon atoms sp hybrid orbitals, and they would share their electrons with the opposite spin. Similarly, the other one sp hybrid orbital of the other carbon atom would overlap with the 1s orbital of the hydrogen. So here there is one sigma bond between carbon and hydrogen. This is the sigma bond. Then this carbon and this carbon are also forming one sigma bond by the overlap of sp hybrid orbitals. This is between carbon, and this carbon also forms one sigma bond with the hydrogen, that is this one. Now if you look back to the electronic configuration of the carbon atoms, then you would come to know that there were two unhybridized orbitals. The one was 2py. Here there is one 2py orbital of this carbon atom, and this carbon atom would also have unhybridized 2py orbital. So here these two carbon atoms would interact with each other with the help of these 2py and 2py orbitals. So these orbitals would interact with each other, and their electrons would also interact with each other to form a pi bond. So this pi bond, we represent it like drawing another line either below or above this sigma bond. So the first line shows sigma bond and the other line would show a pi bond. So let's see that this is the 2py orbital, and there was another 2pz unhybridized orbital with each of these two carbon atoms. So we draw that 2pz orbital in this plane. Here this is 2pz orbital, and here it is also the 2pz orbital, and these 2pz orbitals would also interact with each other to form another pi bond. Here there would be a second pi bond that would be drawing a small line over the sigma bond. So in this way, here it would show a triple bond between carbons, and that would indicate that there is one sigma bond and two pi bonds between two carbon atoms, and there is one sigma bond between carbon and hydrogen for this carbon atom also and for this one also. Both of these carbon atoms would have carbon-hydrogen sigma bond. And the bond between these sp hybrid orbitals, like one sp hybrid orbital is drawn in this way and the other one along this side. So the bond angle between these two hybrid orbitals is of 180 degree. That means that there is they have the linear geometry. So in this way, the structure of ethyne can be justified with the help of hybridization, and especially the sp hybridization. So that means that there is 50% S character and 50% P character in the case of ethynes, or in the case of hybridization, that is sp hybridization. So thank you very much for watching the video. Please subscribe my channel and press bell icon. Allah Hafiz.